Unit 5, Standard 6. This video will focus only on Level 1, which is given an equation that's already in slope-intercept form. We have to be able to identify the slope and give the parallel slope and the perpendicular slope. So the first thing that we need to do is go through a few definitions. The first definition is parallel lines. And parallel lines are lines that are the same distance apart. So think of railroad tracks. Those are the same distance apart no matter where you're at on the railroad track, no matter if you're on a railroad track on the East Coast or the West Coast, they're always the same distance apart. That means that parallel lines will never touch. So when we look at this graph, some things that we notice about these lines. First of all, I notice that these lines are the same distance apart and those lines don't touch. They were kind enough to give us the equations to these lines. And when I look at these two equations, I notice that the slope, and remember that's the number in front of the x, is the exact same number. It's -2. And I could count that out from the equations given to me as well. Down 2 over 1, down 2 over 1, and for this line, down 2 over 1, down 2 over 1. Their slopes are identical, and that's important information. So we have the same slopes when they're parallel lines. Now their y-intercepts, though, are completely different, and they do have to be different because otherwise we would end up with the same exact line, one on top of the other. So parallel lines have the exact same slope, and their y-intercepts will be different. Let's see if we can take that principle and identify the slope of a line that's parallel to each of the lines below. So here's an equation. It's in slope-intercept form. I know that because y is all by itself and I don't see any parentheses anywhere, which means that I should be able to identify the slope of this line by identifying the number in front of the x. That is my slope. If we know the slope of this line, then we should be able to find the parallel slope. And that should be the same exact slope as the line that's given. So the parallel slope is 3/4. You might also see parallel slope written with two sideways or slanted lines. That just means parallel. Let's take a look at the next one. So it's in slope-intercept form. So I need to identify the slope. That's the number in front of the x. That's my slope of this line. So to find the parallel slope, remember the two slanted lines, that means parallel. And m is the variable we use for slope. Parallel slope, it should be the same exact number. Let's do one more with parallel and we'll move on to see what perpendicular looks like. It's in slope-intercept form, so that number in front of the x tells me it's the slope. That's my original slope. So my parallel slope should be the same exact number. Let's take a look at what perpendicular would mean. So perpendicular lines, those are lines that cross at a 90-degree angle. So they're going to look like they are a corner, or think of our four corners at school. Those are crossing at a 90-degree angle. They're perpendicular hallways. When you look at these equations, or these lines cross at a 90-degree angle. They look like the hallways that form the four corners at school. And let's look at the actual slopes that are given for the equations that they gave for these lines. The first thing that I notice about these two slopes is that they have opposite signs. So perpendicular slopes have opposite signs. The next thing that I notice is that it looks like that they're just flipped over from each other. So if I flipped 1/3 upside down, I'd get the 3. If I flipped 3/1 upside down, I'd get the 1/3. And we call those reciprocals. So a fraction that's been flipped upside down is a reciprocal. And just like with parallel lines, our intercepts are different as well. So our slopes are where we find the important information. Perpendicular slopes are the opposite reciprocals of each other. They have different signs, and we flipped the top to the bottom and the bottom to the top. So let's practice doing that really quickly down here. I wrote 3 slopes out for us to practice with. The first one is 3, and we know that 3 is really 3/1. So if I want the perpendicular slope, and just like parallel, we use 2 slanted lines, perpendicular, we can use an upside down T. So the perpendicular slope, we first know that it's the opposite sign. So this was +3. That means our perpendicular slope will be negative. And then reciprocal. That's why we wrote this as a fraction. We're going to flip that 3/1 upside down to become 1/3. Let's do it again here. So that upside down T, remember, means perpendicular. The first thing we know about perpendicular slopes is they're the opposite signs. So that means that my slope is going to be a positive number. And this is already written as a fraction, so I can flip it upside down quite easily and say 3/2. And then finally we have 5/7. So if I want the perpendicular slope, there's our little upside down T, there's our perpendicular sign. Opposite would mean negative now because it was a positive, and reciprocal would make it 7/5. Just like we did with parallel, let's do a little practicing with perpendicular slopes. If they gave us an equation, could we find the perpendicular slope? So this equation is given to us in slope-intercept form. Again, remember level 1, they already give it to us in slope-intercept form. Our job is identify the slope and then name the perpendicular slope. So the slope is the number in front of the x. That's my m. That's my slope. So my perpendicular slope, there's my upside down t. Perpendicular slope would need to be the opposite sign, so it's going to be negative. And we're going to flip that upside down, the reciprocal. -4/3. How about the next one? It's already in slope-intercept form. Y is by itself. So the number in front of the x tells me what my original slope was. So my perpendicular slope, it was negative. My original slope was negative. So my perpendicular slope is positive. And you don't have to write the positive. I'm just helping us remember that it is an opposite sign. And this was a -2. It doesn't look like a fraction, but we know that -2 is really -2/1. So when I go to find the reciprocal, I can make it 1/2. Let's do one more before we practice finding both parallel and perpendicular of the same equation. So slope-intercept form already. So here's my slope, the number in front of the x. So my perpendicular slope, there's my upside down t, that means perpendicular. It was negative, so I know it's going to be positive. This time I'm not going to write the positive because I think we have that idea down. And it was 1/5, so the reciprocal would make it 5/1, or you could just write it as 5. We tend to like to write our slopes as fractions because they help us graph them later on, but either one should be acceptable. Let's kind of put all this together. So in this equation here, I need to first identify my slope. Anytime they ask you anything about finding the slope of a line that's parallel or a slope of a line that's perpendicular, step one is always, what is the original slope? It's already in slope-intercept form, so my original slope is just -2/7. Now that should make you very happy because parallel is real easy, -2/7. It's perpendicular that requires a little bit of work. Not a lot, but just a little. It was negative, so we know my perpendicular slope should be positive. It was 2/7, so the reciprocal of that would be 7/2. Let's take a look and make sure that we know how to enter that in on formative. So here's our level 1, our parallel slope. We needed to enter it in as -2/7. Our negative button is just the button or the key next to the 0 at top. And if you do 2 and then the same key that the question mark is, that's the /. And these should automatically change those to fractions for you. So 2/7. Let's enter in the 7/2. So 7, and then again, that question mark key, it has the / on the bottom. If I press that, it automatically changes it to a fraction, and I can make it 7/2. So remember, we're not really paying attention to what these are, number 1, 2, 3, A, B, C. We really want to make sure that we match the circle 1 to the circle 1 answers. This is asking for the parallel. So here's where I put parallel. Perpendicular, here's where I put perpendicular. Let's go ahead and finish up our notes here. So first step is to find what is the slope originally. The original slope is 3. So that means that my parallel slope should also be 3, or you could write it as 3/1, either one. And then perpendicular slope. The original slope was positive. That automatically tells me perpendicular should be negative. The original slope was 3, or you could say 3/1. So the perpendicular slope would flip that upside down and make it 1/3. Last one here for level 1. First identify the original slope. There's my original slope, 5/4. So that means that my parallel slope is 5/4. My perpendicular slope, it was positive, so my perpendicular will be negative. 5/4 will flip around to become 4/5.